Hi everyone, it's Victor here. Um, yeah, and I'll just walk you through step by step um, process on how we can deploy machine learning models as APIs. Right. So we talked about this during the workshop, the Zindi workshop we had, and a lot of folks requested that I do a step by step walkthrough so that they can follow alongside and replicate the same. So that's what I'll do very quickly in this short video. So essentially, um, we deployed an open source um, hackathon that was held quite recently. I'll just try to filter here by newest, right? And if you check it, you see the DSN and Microsoft Skills for Job, right? And essentially, this the objective of this hackathon was to create a powerful and accurate predictive model to estimate the house prices in Nigeria, right? It was a regression task, and essentially, what you were supposed to come up with as your final prediction is the house price, given a particular data set. So we're giving some data, and yeah, we build a model and come up with a model and submit, right? But for this workshop, essentially we're looking at how to actually deploy these machine learning models as APIs, right? So that the front end or developer or anybody within the web team can just pick your API and integrate it with a website, right? So that's actually a very simple task. But to do that first, I'll just walk you through the notebook. So we already have a notebook, right? Yeah, and this is it. Okay, so I'll just open the folder real quick so that you can see everything at a go. So to walk you through the notebook, this is the deployment notebook that was used. So it's actually pretty straightforward. Essentially, what we did in this first block of code was to import, several libraries, which, of course, you presume you'll need along the way, right? And yeah, we just load in the data sets. So we have housing dataset train and housing dataset test, as well as the sample submission, right? So if you check out the train set, you'd see we actually have IDs at the location. So these are several states in Nigeria, right? Then title, it's quite funny, having the name title, but essentially what you have there is, different types of buildings, right? Apartments, detached duplex, terrace, bungalow, and the likes. Then you also have the number of bedrooms, right? And that's why you see 2 bedrooms, 7 bedrooms, etc. And so also for bathroom, parking space, and this is the target variable, which is the price of the house, right? So what I do in this next line of code is to simply check if their price is less than zero. Of course, prices cannot be less than zero, definitely. So you definitely want to drop any of such occurrence. Just to check out the description to see the count, the mean, the median of the numerical columns there, right? Then I also check out the test set just to see have a sense of what it looks like and what we'll be predicting, right? So these are the unique house types, semi-duplex, apartments, etc., etc. And yeah, to also um, you know check out if we have missing data for the rows, right? So we find out that we have quite some amount of missing data. Then we also drop the price so that we can combine the train and test and do the pre-processing at once, right? So on checking again, so this is actually a plot of the missing values for each column, right? Just to move on very quickly, because this is just like a baseline notebook, right? So what we do here in this next line of code essentially is to map the house types. So we have apartment, flat, cottage, etc., etc., right? So we map them to numerical values. What I actually tried to do here was to try to rank the house sizes. I'm not sure this is really accurate, but you can do your own edits, and make sure it's quite accurate, such that cottage comes first, on and on and on down to mansion, and see if you get a better score. And yes, also, um, you know map the states as well. Try to just map the states as well, to numerical values. Then on and on, we don't need the ID, so we can drop that. um, and yeah, just get ready to train. But before training, I just decided to do something real quick, which is to check the distribution of the target variable, and you can see it's left skewed, right? But when you log transform it, you see you have quite a normal distribution here now, right? So on and on, right? I trained a simple cat boost regressor, right? With just 100 estimators. As I said earlier, this is just a baseline notebook, so we can learn how to deploy, right? And yes, the feature importance plots. You can see that the location seems to be the most important feature, and the parking space seems to be maybe the least important feature. Yes, and to save your model, it's just, I mean, it's a single line of code, right? You import job lib. For some that already do this, they might be familiar with Pico, right? So but I'm using job lib in this scenario, and essentially you just say job lib.dump, then you dump your model. Remember that the model is what you have initialized and you have fit uh, you know the data with, right? So that's what you dump, and you give it a name, right? And that's all. When you do this, you get a file at the side called catboostmodel.pico, right? Yeah, you'd see I already did the same earlier also for light GBM. So yeah, that's why you see a light GBM here, right? And yeah, you can also try that for several other models that you build, right? So I'll just move on to what we do next, right? So essentially, you have uh, the model already. This is it. So when you say your machine learning model, you've built an AI. Essentially, what you've built are just you know values which have embedded into this Pico file here, right? Unfortunately, we can't open it, but maybe you can try to open it with your text editor and see what's inside, if you want to, right? So next is to build the Flask app, because we've talked about building APIs, right? And when you talk about APIs, essentially it means you want to make calls to a server, right? So when you have APIs, essentially you want to do a get request, or you want to send a post request, right? There's several other requests as well. There are very popular requests like puts and so on, right? But essentially, post and get seems to be some of the most familiar, right? And we would see some of all that and test it as well on Postman. So to do that, Python has a very popular. Let me just show you that. Python has a very popular framework called Flask. So you can check out Flask on PyPy. Um, yeah, so it's a very um, popular framework used in the web, right? And as written here, the authors have said it's designed to make getting started quick and easy, with ability to scale up complex applications. Yeah, so it's a very light and easy framework. Some as well also use Fast API, which some have claimed is quite easy as well. Yeah, but for the sake of this demo, we'll just stick with Flask, and see how that works. So, but yeah, sure, you can definitely also check out Fast API if you want to try your hands on other things, right? So I'll go back to the notebook, and this is another file which I've written. It's called app.py, right? A Python file, and this Python file essentially is the Flask app that runs on the server, right? And funny enough, what you'll find here is I just have, I mean, the actual code is less than about 15 lines, right? And that's because I've even added, a lot of comments and jargons there. If I'm able to shrink this down very strictly, you should get about 7 to 8 lines maximum, right, of all the code you need to actually deploy this project. Okay, so but to do that, right, um, I'll just walk you through a rundown from the beginning, right? So I I, I import Flask, right? So from Flask import Flask, then I import request as well. So request handles your request from the client, where your codes will be in the server, right? Then you also have JSONify to help you handle response and ensure that those responses are in JSON format, which is very popular uh, when dealing with APIs, right? Then you remember the job lib, which we used to save the model. We'll use that again to load the model back. Then pandas, pandas is pandas, anyways, right? Just to ensure you have your tabular functionalities here. Okay, so what I what I usually like to do when I'm about to start building an API is to define exactly what I want the client to send me, right? So what I've defined here is the client sends me location, called loc, LOC. He sends title, he sends bedroom, he sends bathroom, he sends parking space. And when the client sends this, of course, and the corresponding values, I send back the prediction, right? That's it. So it means that any client sends you this data, you are able to send back through your machine learning model the house price based on these parameters, right? And of course, the reason why I like doing this is because it helps me to structure my code, and I'll be able to understand how best to actually write this code. I'll show you shortly. Okay, so for the location, you see I'm taking strings, right? That's Castina is the name of a place, a state in Nigeria. You see for title, which is the house type, you see I'm taking a kind of house type as well, semi-detached duplex in string. But for bedroom, bathroom, and parking space, you see, I'm taking numerical values, right? So it means that, um, of course, your model only understands, numerical values, right? So it means that you'd have to map it, right? And mind you, you would have to use the exact same mapping you used during building your notebook, right? So I copied this, and I pasted it here, right? I just gave it another name called state to int. That is, these are states, converting them to integers, and the house types as well, right? And the reason why we have to do that, I've mentioned earlier, is so that when the client sends the location which we're expecting a string, you can easily convert it yourself in your code, right, before pushing it to your model. So the first thing you do when you are writing a Flask app, as I've said earlier, the Flask app is just 15 lines. So if you take a good look at it, you are going to get it. And once you have the framework, I mean, once you're able to do this, it means you're able to do for the same for several other machine learning models you want to build in the future, right? Okay, so first of all, you initialize the Flask app by saying app is equals to Flask underscore underscore then name. And do you see the reason why I did that? Yeah, so that when you immediately you start up the server runs the Flask app immediately, right? So if name equals main, which it is, every time when the server runs, app dot run, this is what runs, right? And the app is actually the Flask app, right? So what you do is you start with initializing the Flask app. Then of course you want to load in the model, right? So your cat boost model which you've built and you've saved, you just bring it back in. It's as simple as one line: model equals joblib dot load your cat boost model, right? Then now we have endpoints, right? So for beginners, you might not be familiar with what endpoints are. So I'll just show you real quick, right? So what endpoints are is essentially, okay, so when you have like a main site, you have a main link. So for instance, you have Zindi.africa, right? So this is the main URL, right? and you can have several endpoints in it, right? Slash competitions. So your slash competitions is, the endpoint for uh, this website, right? So you have slash competitions, which is a page, right? And you have slash maybe hackathons, right? You have several other endpoints, right? So that's exactly a similar way, right, in which the backend endpoints are. Most people into full stack web development are folks that are familiar with these things, but they're actually pretty easy. And I mean, just to build something real quick, it could really help you get started, right? So the slash, this one that says app route to slash, is the index, right? Just like when you say, let me pull up the browser back. So just like when you say Zindi.Africa, then you just leave a slash, right? So this just takes you to exactly the URL, right? So that's like, some people call it the index, some people call it home page, some people call it landing page, right? So whatever you want to call it, right? So I'm just using that to explain a get request. Yeah, so I'm just using that to explain a get request. And then you see, I wrote something really funny here, and I actually like to do this so that I can know when the API works fine, right? And yeah, just ensure things are going fine on the API. So for the landing page or landing page, as if I may, or the index, right? Uh, I'm returning a simple string, and I'm just saying hi. This is a get request to show that the API works. Welcome to Zindi, the workshop. I should probably say the Zindi workshop. Alright, let me just edit that. Alright, and I have a smiley emoji here, or a wink. Yeah, so this is the code. This is the main code. The endpoint is called slash predict, and essentially this is where you make your predictions. So it means that the client would have to post. You can see the request is called post, right? Because it's actually sending something to the server, right? So the client makes a post request to this endpoint, right? And of course, it sends this. It sends this JSON file, right? Or this JSON formatted text there, right? And what you do now is you define what that endpoint is. And so what you do first is to collect the data from the client, and it's as simple as just saying request.get JSON, right? So when you do that, you actually have collected your data from the client. So it means at that moment, data is now equal to this JSON file you have here, or this JSON text that is there, right? And of course, you can print data. Well, I mean, obviously, you would only be able to see that in the console, but I'll just move on. Right. So what you have to do next is to just pick that data as it is, and give it to the model. Right. Of course, you would have to note that your data that you are requesting has to be in the exact same format you trained your model. Right. And that's why you see I was very careful in writing this endpoint, right? I started with location, title, bedroom, bathroom, and parking space. And you see, that's exactly what I have here: location, title, bedroom, bathroom, and parking space. Remember, I dropped the ID before I trained. Let me scroll to the end so that you can see that really clearly. Yeah, so you see, I dropped the ID. So it means that what I trained in my model was just location, title, bedroom, bathroom, and parking space, which exact the exact data request from the client, right? Okay, so after getting that, right, I just put it in the data frame. Of course, this is, well, there are several other methods you could just predict directly on the JSON, but I like to just make it in a tabular format, just like the test set, right, before giving the model, right? So you could experiment with, I mean, several things. You could also stick with my strategy if you may. Then what I I'm doing next here is to now map the features, right? The strings, right? So the title and the location, right? So I map them using, of course, house type ranks, and so those two dictionaries I've created, house type ranks and state to int, right? So state to int, house type ranks, I map them. So now those strings are now numerical values, correct? And next, I simply say model.predict. Remember, we've initialized model already, saying joblib.load, right? And just simple as saying model.predict. And when you do that, you get your prediction. As simple as that. So I'm returning a response, and I'm just saying in my response, price prediction, and I put a semicolon, and I write the value of, the prediction. And the reason why I zoom into zero or I drill down to zero there is because this actually returns a list, right? And the value is, of course, the only value in the list. So yeah, you definitely want to check that out and see how it plays out. Okay, so when I'm done with all that, I JSONify this response, which is still a dictionary here. So I JSONify it and, of course, send back to the client, right? So you can see it's very simple. The client provides me with the data, I make the predictions, and I send back the prediction to the client, right? So that's what an API is essentially, and it's called, as you've seen, an application programming interface, right? And helps you to easily help the front end guy build your work faster and integrate with whatever you intend to deploy as a machine learning or a person, or a data scientist. Okay, so now that we've built all that, we want to deploy this because it can't sit on our laptops here. It has to it has to work on the cloud, on a server, right? I'm going to do something real quick. I'm going to try to run this. Okay, so just give me a second. I'm going to open my Anaconda Navigator. For some issues I currently have with my environment, I have to run through Anaconda. So I'm just going to open Anaconda Navigator now and rerun. So we are in. So I'm just going to run this. So this is the app.py file. I'm going to run this. So run without debugging. Okay, let's see what's happening here. Yep, so you can see this is a development server. Do not use in production deployment. That's because we are running the Flask app directly locally just to test, right? So on the servers they actually use production servers, right? Like WSGI, and you saw how all that works shortly. So you would see I've been provided with a local host link, right? This link only works on my PC because I'm testing locally and using my PC as a server, right? And there's a very popular app called Postman, and if you don't have that, you can easily download that. Postman allows you to make post requests, right, and several other requests, because you can't do that conventionally with the browser, right? The browser can only make the post requests, the get requests, right, when you ask for web pages, right? But for post request, you need an actual code to post that, right? So I'm going to show you now how the post is done, right? So I'm going to paste. Okay, I'll just go back to this, then you can copy this, so you can just copy back to Postman and I'll paste it there, right? So I'm going to send a get request, and what am I expecting to see? I'm expecting the text I wrote earlier. So if I go back there, I'm expecting this text: hi, this is a get request to show that the API works. When I get I try to request for the endpoint, right? So either you put a slash or it just is basically the same thing. So I'm going to send, and you see this is the response from my local server, right? So let's do a post request. So you can see there are several other requests, right? Put, patch, delete, there are several things you can try out, right? And you can always Google to find out, what they involve or what they do, right? So if you remember, the slash predict is the endpoint that makes, the prediction for my machine learning model, right? So I'm going to, it means I have to put a body, right? Because you are making a post. So what am I going to post? I'm going to post my example. Let me get it. So this is my example. I'm going to post it. So I'll just say raw. Remember, I want to post a JSON, so I'm just going to select JSON. And yeah, I think we're good. So I'm going to post. Yeah. Ooh. So I got it right. So this is the price prediction, and this is the actual price returned from the cat boost model, right? So you'd see, yeah, as easy as ABC, right? And you can just view the logs to see if there were any issues. Okay. Right. Okay. So this is the one I'm using, and you can see there are no issues. And if you remember, I put a print somewhere in the code to print the data, right? And yeah, so this is the data printing right here in the code, right? But of course, nobody's going to see this. It's going to be on a server, so yeah, you can definitely use that to debug or view logs, or see what's actually happening within the code. So yeah, so this is how it works. You can see it works fine now. And yeah, to deploy you basically need one more file, and I'm going to stop running the server now. So you need one more file, and that file is called a requirements.txt, right? A requirements file. So, and what the requirement file entails, basically the libraries you used while building the app, right? So remember, we don't need this notebook anymore. The notebook you used to build the model, we can as well discard it, right? And what we need is the app, the py, right? We need the model, of course, the catboost model, because we are going to call it into the app, right? And we also need the requirements.txt file, which contains the libraries that you used in the app, right? Because when you deploy to a server, you'd have to give instructions so that the server can install these libraries for you and make it available, on your cloud servers. So we used Flask, we used JobLib, we used Pandas, right? Those are the three libraries majorly we used. And of course, since I'm using a catboost model, I also decided to add the catboost I used as well. Then G-Unicorn as well, which I mentioned earlier that for deployment you use WSGI servers for production, and unlike just the convention that you use in testing, right? All right, so this is just for development, right? So yeah, so the G-Unicorn comes in handy when you want to deploy. All right, so with that said, I'm just going to show you how it's done on Azure. All right, so I'm going to open my Azure account. So you can just go to azure.com, and Azure is owned by Microsoft. It's their cloud deployment solution, right? They have tons of deployment plans, deployment servers, and several cloud computing capabilities are there for you to take advantage of, right? So you can just try to log in, or sign in, or create an account. I'm just going to sign in. Okay, so I'm already logged in myself, so it should just sign me in automatically. Alright, so I'm in. Yep, and yep, you can see it's all good, from my end, right? So you can just go to create a resource, and you see there are several resources you can create, right? You can do well to just check around through the resources that are available. But specifically, we need what is called web app, right? So we need a web app, and I'll just open that for you now. All right. So this is the web app. Um, I actually have an Azure sponsorship subscription right now, and you yourself might also have. If you're a student, you can leverage the GitHub. So you can just go to education.github, and you can take advantage of the students packages that are there, right? So you can just check out the GitHub Students pack, where you can request for benefits, right? So just do well to sign in and find your student benefits. I've already activated mine, so yeah. Anyways, so on getting back here, yeah, you can just select the default resource group, or you can create a new one if you may. In fact, I'm going to create a new one. Just going to call it Zindi workshop. Okay, yes, so you cannot leave space. Yeah, so you can just create a new one, and you give the web app a name, Zindi workshop. Yep, I think that's cool. So what I'm going to show you now is, there's something really interesting I like about um, um, the Azure web app, is that you can actually deploy codes directly from a Git repository, right? Stuff like GitHub, right? GitLab, etc., etc. Okay, so I'm going to put my codes on GitHub now. Probably I should finish this up, then I'll do that later. So let me just finish up creating the runtime, right? So Python 3.9, then you can choose your region. Yeah, of course, any region closer to you is fine. I think South Africa is probably the closest, but yeah, South Africa does not have free plans, right? So if you are looking for a free plan, you could probably check US Central, East Asia. I mean, many of all those other data centers have a free plan. So you can see there's a free plan, right? In case you're unable to, access all these other plans due to your billing, right? So I'm going to use the basic plan, just for just for the sake of this. But of course, you can use the free plan. Is also fine. It's going to work. Okay, so next you can just leave others as defaults, and you can say next deployment. Right. Okay, so GitHub Actions settings, right? So this is where we'll need the CI/CD, right? I'm going to show you how to do all that, right? And CI/CD essentially means continuous integration, continuous deployment, right? And what it essentially means is it allows you to seamlessly, translate your codes to whatever you have on the production. So it means that as you make changes in your codes, right, and push to GitHub, this automatically, pulls it from GitHub, and corresponds those changes to whatever you have in your server. So I'm going to enable this, and this is where you have the opportunity to actually select the repository, right? Or you can disable and of course enable later. It's all up to you, right? So we are going to do something real quick. We are going to create a repository, right? Why just pausing what we have here on the web app now, right? So I'm going to create a repository. I'm going to go to my GitHub page. Okay, github.com. Okay. So I'm here in my GitHub page, and of course you can definitely come out to check my GitHub. I have several notebooks, and I'll be deleting most of these repositories soon, because I've created a new repository called where is it? I'll try to find that. It's called Zindi notebooks, where I've combined all my top notebooks as well as my starter notebooks, so that you can take advantage of it and leverage in your next competition or hackathon. Right. So I'm going to create a new repository for this project. I'm going to call it Zindi Workshop. Zindi Workshop. Right. And of course, we can leave it public. If you want to read me, you can add a read me and create a repository. If this is your first time using GitHub, it's as simple as just going to github.com, opening an account, and just saying create a repo, right, a repository, and yeah, voila, that's how you create a simple repository. And you want to add codes next, right? So you can add codes by just saying add a file, and you could just upload files, right? Yep. So you could either do a drag and drop, right, or you you choose files and you navigate to the folder where it is. So as I mentioned earlier, we only need the app, correct? We need the calboost model.pico file, and we only need the requirement.txt, right? That's all. Other things are, extras. If you want them, you could just add them up here, for the sake of, yeah, it depends on you. Well, don't worry, I'm going to share all these files. I'll most likely zip them and add them here into the repo, or I just, add everything as it is. Yeah. So I'm going to commit the changes. So when you say commit changes, it just means, you are done making any change and you want to commit, right? So here we are. We already have link, repo, all set up. So we want to point to this repository from our Azure, right? From our Azure accounts, right, on our servers. And sometimes, if this is your first time as well, it might prompt you to connect your GitHub account, because mine is already connected. So it might prompt you to connect. So that's pretty much straightforward, right? So you can see there's even a place I can change accounts at the moment, right? So I'm going to enable this, and yeah, I'm going to select my own account. The reason why it's showing two there is because I have an organization as well on GitHub. But yeah, conventionally, if you don't have one, you should just show your username, right? Then you pick the repository. Remember, this is Zindi Arc. No, this is Zindi Workshop. I think I've created so many of these repositories. So this is Zindi Workshop. Yep. And yeah, definitely the main branch, right? So this is it here, the main branch. And if you want to preview the file, because what's happening at this moment is that Azure automatically creates a YAML file for you, which is called GitHub Actions, right? So it creates that workflow where it's seamlessly takes in your codes from GitHub and makes them available, right, and deploys them on your server, right? Okay, so I'm going to go to networking. You can leave the defaults. You don't really need to change anything. The tags, you could leave them, and yeah, just review and create. So when you're all done, you can just select create. So as I clicked on create, you can see it says initializing deployment to a resource group, right? To the resource group I created. And a resource group is just simply a collocation of resources, right? That will be used for your particular deployment. Okay. Right, deployment is still in progress. You can just hold on. Alright, to show you something really interesting while deployment is still ongoing, right, I would navigate down to my GitHub repository, and you'd see, on refreshing, you'd see a new file has been created, right, called .github/workflow, and that was created by Azure, right? Because it creates the YAML file which I mentioned, that contains the GitHub actions. So this is it, right? And yeah, that's essentially the GitHub actions. And you can also go to actions down here, and you see what actually happens behind the scenes as it builds and deploys your application. So it's installing the dependencies as we speak, right? Installs them, completes the job, clean up of and process, and now it's in the deployment stage. So starting job, connecting, is waiting for the runner at Azure to pick up this job. Yep, set up, and now we're deploying directly to Azure at the moment. Alright, while I'm waiting for this, let me just show you what's happening at Azure at the moment. So you can see back here on Azure, it has created my server, a space for my project to be deployed, and everything has all been set up. So I can just go to resource, right? And when I go to resource, I'm going to see everything that has been set up for me seamlessly by Azure. Alright, so you can see deployment is in progress. So this is it, last deployment, currently in progress, which is built by the GitHub action files, right? And you see I've been given a website, right, which is quite interesting. I've been given a URL, zindiworkshop.azurewebsite.net. So that is my personal URL for this project to access the contents of this server, to make my post request and to make my get request. So when that is done, you would see how it works. So I'm just going to wait for this to complete, and then we're going to check out the link and see if it works. Alright guys, so it's actually complete. I had to actually wait for about 8 minutes and 44 seconds, and just in case you are wondering what kind of time frame it's going to take, right? So I'm going to navigate down here, and it says still in progress, but I'm going to refresh. Let's see. Alright, it says successful. So I'm going to try out my link now, the default domain which I've been given. Alright, and it works. Mind you, run this might take a while if it's the first time, but subsequent loading ups will work fast. So you can see, as I mentioned earlier, browsers actually send GET requests, right, to servers, right, and you see that it says, hi, it is a GET request to show that the API works, and this is a real, URL, right, and yeah. So let's try out the post request. I'm going to copy my link. So I'm going to copy my link. You can just copy, or you open it and copy, anyone. And I'm going to test with my postman. Right. So I'm going to test with my postman. I'm going to test the GET request first. And the endpoint is just, no endpoints. It's just the index. I'm going to send. You can, of course, you can leave the raw there. It's not going to send anything since it's a GET request, right? So you can see I'm getting that from my server, which is on Azure at the moment in the central US, and I'm going to test the post request as well, and this is it. I'm going to send to the endpoint called /predict. Now what happens if I send a post request to to this endpoint? You find out that the server crashes because it's not allowed, right? I didn't allow. So if you check through my codes, you remember clearly there's a place, part of the code, where you have to allow specifically if you want methods, right? The kind of request you want, right? So so it means I can't post there, but for my /predict endpoint I can post, right? and when I post that, you can see I get my price back. Right, so this is the link you give to the front end developer working for you, to continue building the front end. Right, so he sends requests to um, this kind of format to your server, right, and the clients, or whoever is developing, gets the feedback back in JSON, right? So you can keep on building APIs, and feel free to reach out if you face any challenges, and hopefully you gained a lot through this tutorial experience. And thank you once again for joining me. You can always reach me on Twitter, most preferably LinkedIn, and I'm available on the group as well. There's a Zindi group on WhatsApp, so you can reach me on any of those platforms, and I'll put the codes available, make everything on GitHub, and this video will be available on YouTube as well. Alright, guys, thanks again. Have a lovely day. Bye.